Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode, we're going to be talking about some crazy advanced topics. I got a request a little while ago from a guy on a video, Michael Moore, I believe is his name, and he wanted to know about putting story into games. And one of the things that he mentioned there was dialogue trees and AI. Those are two separate systems, so I'm going to start off with the more easily implemented AI. Well, easily implemented in a dumb way, AI. Dialogue trees can be kind of complicated because that implies a lot. So, for example, an AI system is pretty easy to do because it's just objects moving around and obeying certain predicates. But a dialogue tree implies some sort of way to interface with an object, and then you need to have the some sort of a UI system in place that can then display text and things like that. So dialogue trees in a system like that is multiple systems combined into kind of like multiple subsystems combined into a large system, whereas AI is kind of sort of the same but much less complicated. So I'm going to cover that first, and you'll notice that this isn't a blank Unity scene. I've done things, so let me explain what I've done. I created a new scene called AI stuff, and there's a folder there. We'll talk about that in a second. But I created a new scene called AI stuff, and I placed some things in here that have colliders, boxes, and I kind of created an environment. So I have a ground that is a... oh, I don't need this anymore. It's just a quad with a mesh collider on it. So it's just a basic quad that I scaled up to 100 and rotated a little bit. And I threw these boxes in to create kind of like a pseudo environment. Because we're going to be focusing on pathfinding today and AI and Nav Mesh and things like that, we want an area for the AI to run around in, and Nav Mesh between it's interesting. So I thought that this was interesting enough to warrant that. I've also done some tagging and some layering and stuff like that. But for the moment, I just have this wall 1 with a wing and a wall 2 with a wing. I have a hub, which is just an obstacle in the middle, and I have some, and I'm going to delete some things here because I was doing some examples. And yeah, that's basically all. I have directional light and a camera. It's nothing fancy. This is an empty game object to house everything under so I can organize everything nice, but this is all stuff that we've seen before in the first-person shooter video thing and stuff like that. I have scripted some stuff, and I have done some examples that I will explain through the video, but for now, if you're following along, just create a new Unity scene, put a plane down that has a collider. Go ahead and feel free to pause the video and do all this stuff. Put a quad down that has a collider on it and some boxes or whatever you want in the environment. It doesn't have to look like this. It just has to be stuff in the environment with colliders on it that we can use. Once that's done, the next thing you're going to want to do is, and I'm already going to have a Nav Mesh built in here, and I will explain what a Nav Mesh is if you don't know, but I'm going to have a Nav Mesh built in already. I'm going to delete it. I'm going to show you how to make a new one from scratch. So I'm going to clear, and I'm also then going to show you how to get back to there. So if you go to Window and you go to Navigation, that'll bring up the Nav Mesh, or the navigation window over here next to the inspector. It'll also bring up this little dialogue in the scene view. So from here, I'm gonna like what is a Nav Mesh? If you don't know what a Nav Mesh is a polygon mesh that sits over an environment, and it's usually a lot lower poly, so it has a lower vertice count than the underlying geometry. In this particular case, it's actually going to be higher poly because it needs to be more detailed than this quad. But say that you had like the terrain that you made in Unity, and the terrain is really high poly, so maybe you don't want a mesh that is that high poly, because the vertice count on a Nav Mesh, the higher it is, the longer the calculation time is for paths, because it needs to take into account all of every individual vertice on that mesh in order to calculate the path. So the lower poly the navigation mesh is, or the Nav Mesh, the faster the navigation calculations will be, and you can have more accurate path pathfinding and more intelligent pathfinding depending on how low or high poly that mesh is. So it's kind of a weird way to describe it, but essentially what a nav mesh is, think about it like a roadmap of where your nav mesh obeying things can go. So things like AI, things like an NPC in an RPG, for example, can go anywhere on a nav mesh. They cannot go off the nav mesh usually. There are certain situations where you may or may not want that to happen. Where you may want that to happen, rather. But usually it's not the case. And, yeah. So, to show you what a nav mesh looks like, if you open up the navigation window over here, which we have, the first thing it's gonna ask you in the object tab here is what objects are we using to determine the nav mesh. So usually you want that to be all of the objects, but and by all of the objects I mean all of the objects that your environment encompasses. So things that have colliders on them in the environment. So that's why I was making sure that you had colliders on everything. There's colliders on this, there's colliders on this, there's colliders on this, and the ground. So this is what we're going to use to determine what our nav mesh is going to look like. And you'll see over here that it says I have wall 1, which is that wall there, this wall. So again, I'm going to select all of this. I have wall 1, mesh renderer, and 7 others. What the mesh renderer means is that it's just the object has a mesh renderer on it. And we can determine things by the mesh render, the mesh. This is a filter, so this is looking at just terrains in the hierarchy. This is looking at all the mesh renderers in the hierarchy, and this is looking at everything in the hierarchy. So once you have everything selected that you're going to want to use to determine what your nav mesh is going to look like, there are some options. You can make sure the nav mesh is static, or you can make sure it's not static. What that means is, are we going to be changing the navigation are we going to have a wall that's going to come down and up that is going to then open up a nav mesh channel as we do things? Because if so, then that's going to be a non-static navigation. For this particular case, because it's going to make things a hell of a lot easier, and most of your navigation is going to be static in games, and you can usually find better ways of going about the non-static navigation, we're going to make sure that this is static, because this is a static environment. Nothing in here is going to move for our first example. Off-mesh link generation is going to be, it's kind of complicated, but if you think about it like you have three floating platforms, and you want your AI to be able to move between them, each platform is going to have its own chunk of nav mesh on it, right? And you can use off-mesh links to bridge those different patches of nav mesh. So if you have an island of nav mesh and you have another island of nav mesh, as a matter of fact, here I'm just gonna. So if we wanted to have this here, and then this here, and this here, and we wanted our AI to be able to go up this and then run across here and then up this and then maybe jump from here to there, we would have to generate off-mesh links, because each one of these is going to create its own little patch of nav mesh on top of it if we tell it to. And then we also want it to be able to generate links between these meshes so that we can tell our AI to use those links to jump between them. So in a lot of games and in a lot of games there are animations that you would play when they do that. For example, in this particular case, it would probably be a jump and like what would you call it? A jump and climb up. So they would jump up to the ledge and they'd pull themselves onto the platform. That would be the animation that they would play as they're using the off-mesh link. And the off-mesh link is just a line from the edge of this nav mesh to the edge of this nav mesh that says this is where you can move between nav mesh points or nav mesh patches. So if that makes any sense to you, awesome. I know this is kind of an advanced topic, by the way. Just try to stick with me. We're not going to be talking about off-mesh links. I just kind of wanted to say what they were, so because I mean, they're in there. So if you don't understand it, that's fine for now. Play with it in your spare time. because they're useful to have. So yeah, that's what off-mesh link generation is. We're not going to be doing that. And then the navigation layer is what kind of navigation is this, or what layer of navigation is this going to be filed under? Can you not walk on this? Can you only jump to this? We're just going to run default because this is just going to be a normal nav mesh. So the setup for this is basically just open the window, select what you want, and make sure it's static. And then after you're done with that, we're going to go ahead and hit bake. Once we hit bake, you're going to see a bunch of stuff happen up here. This is what a nav mesh looks like, in Unity at least. You'll notice that it doesn't go all the way to the edge. There's a reason for that. And it also doesn't go all the way up to the objects in here. So going back to our window over here, when we have everything selected, if you go to the Bake tab, you'll see a bunch of stats to modify how it creates the nav mesh. The radius here, a 0.5 radius, is what is happening here. It's creating a 0.5 radius. If we increase this to 1 and then we hit Bake, it will make that bigger. The reason why you do this is if you have an object coming along from this point to this point, and it needs to go around this, you want to make sure that anything hanging outside of the bounds of the character, so like if it's a humanoid, then you would have arms. You want to make sure that his arms and shoulders don't clip through the corner of the object. So usually you want a little bit of a give in there. Now, if you make this 0, well, first off, it won't let you make it 0. I think it has to be 1 at least. Can you make it 0.25? You can. Oh yeah, because it was 0.5 to start with. So you can make it like 0.01, and then you can hit bake, and it's going to be really up close to that that object. It's also going to take longer to bake. Oh, this could be not good. I've never done a radius that small before. Let's do a cancel. Cancel. And we're going to do 0.05. 0.05 might be a little better. Okay, yeah, at least the bar is moving. So down here is a little loading bar for when it's figuring out what it's doing. This radius is really tight, so it might actually be it might be a lot higher poly than I'm expecting it to be, because that's taking a long time to turn out. Anyway, this is going to be the radius around objects, that it's like the give around the object for determining how close it is to being there. So see, now it's really, really tight, but we want this to be 0.5, and that'll make sense and I'll explain why in a minute. Well, I mean, once we get to it, why we want that to be the case. The height is how I don't know how to describe height necessarily. How much vertical clearance space? Oh, okay. Oh, never mind. This is the wrong thing. I'm thinking of step height, I think. Oh, I was thinking of the advanced stuff. Okay, so height is pretty straightforward. It's how much vertical space do we need before we say that it's too small of an area and we don't want our AI in there. So, for example, if you had a like a tunnel, like a mine shaft or something, and the ceiling got really, really low at a specific point, and you didn't want if the AI were to walk through that, their head would clip through the ceiling or whatever, then you could determine the height here. So right now the height is 2, so if anything is 1 above, which we can do by doing this, and we can say that you are going to be 1 above, which means that there's only going to be a 0.5 clearance here, because the cube is 1 tall, and the center of the pivot is 0.5 into the cube, which means that this is going to be a 0.5 gap off the ground if we set this to 1 on the Y. Hope that made sense. Anyway, we're going to go over to navigation again, and we're going to bake again with the 0.5, and it shouldn't take very long. And oh, that didn't work. Interesting. Oh, I know why. Objects by default are set to non-static for baking. So a heads up there. When I created this object, I didn't go into the navigation window and set the static on it, so it wasn't including it in the bake. So there we go. So now that this is there, it will cut around it, and it'll do the same thing if I set it to 2, because again, the gap down here is 1.5 now. And if we go to navigation and bake again, we're going to see a very, very, very similar thing happen. See? But if we raise this up to 2.5, it might do it. We're equal to... Yeah, so it's not going to. We have to set it a little higher. So if we do 2.5... Whoa. 2.51, then it should work. I'm hoping it'll work. Bake. So there's a little bit of a... Oh, I know why that is. Alright. 2.6. I know why that is, and I'll talk about it in a second. But if we do that, then this should be working, but it's not. We'll just set it to 3 and pretend that it did what I expected it to. Yeah, so now it's going to generate Nav Mesh below that object because the object is high enough for the clearance. So if you want to, if you want to think about this as undercut clearance, that would be a better descriptor for the height. How much clearance below an object do we need to generate Nav Mesh below it? That's kind of what the height does. Max slope is, I mean, that's pretty straightforward, but just in case you're curious, I will create a ramp. We will generate some Nav Mesh on it. Boop da boop 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 doo. So this is going to be 8. This is going to be 0.125, and this is going to be, I don't know, 3. So the max slope was 45, right? So if we change this to 45 on the X, we end up with that. That's 45 degree. Whoa, what are you doing? 45 degree angle. So if we change this to something like 15, and we scoot this down so that it intersects the ground, and we bake Nav Mesh on this, we should see the Nav Mesh creep up it. See? But if we rotate it even more, if we say take this and make it 45, like we saw, it shouldn't creep up it too much. It should creep up it less if we hit bake. Yeah, it's not going to creep up it at all. Because the max slope is 45. So that is, I'm trying to think of the easy way to say this. The angle, okay, so, well, we'll set it to 40 and see if that generates Nav Mesh on it. I haven't done a whole lot of, like, angled Nav Mesh generation, so I don't know. Yeah, okay, so that worked because it's below 45. So, this is not inclusive. The max slope is not inclusive. I would say that generating Nav Mesh on a 45 degree angle is kind of insane. I would probably tone this back to 30 at the most. And you can kind of play with like the slope of things to see like this. That seems like a reasonable steep ramp. I wouldn't go any higher than that, otherwise it's kind of unreasonable. 15 degrees is probably going to want to be what you're going to want to stick to for level design messaging, for like, I can walk up this ramp. A 45 degree angle ramp is just craziness. If I saw that in a game, I would expect that if I could walk up that, it would be like a bug. It wouldn't be a thing that should be in the game. It's just a thing that is in the game. 30 is pushing it, but you could argue that, and then 15 is absolutely I can walk up that. So that kind of goes to your level design standards, but you can cap that off here. You can say that no, we're only going to allow a 15. Anything higher than 15 is a no-go, for AI at least. I'm going to leave that at 30 though, and point out something else that's interesting that you probably noticed. The Nav Mesh isn't generated dynamically unless you tell it to, obviously, which I'm not talking about in this video. But if you change objects around, you're going to have to rebake the Nav Mesh. So the Nav Mesh is still going up here, and our AI will just walk into space. Because it's not obeying the physics anymore, it's obeying the Nav Mesh. So it'll just walk up into space if we leave this like this. So what we need to do is we need to rebake. And then it'll adjust accordingly. And again, because the height here isn't 2, it cuts it out below it as well, so the AI will never go underneath that ramp, which is fine. We should actually, for the purposes of yeah, we can go 1.5. So now we're going to see the nav mesh creep under here a little bit, I think. Oh, no, we didn't. Okay, that's fine. We'll set it to 1. There we go. Now it's creeped under there a little bit so our AI can wander underneath the high side of the ramp. Just for the purposes of our demonstration, you'll see why in a little while, I think. I'm going to be using just like a sphere, a little 1x1 sphere to move around the environment. So it being able to go underneath this ramp should be a thing. Anyway, going back down a little bit further, so there's off-mesh links, which is kind of what I talked about before with the different nav mesh patches. And, whoa, I unselected everything. That's just the how far away are points on the nav mesh, edges on the nav mesh patches. That's the jump distance. So if we set the jump distance to 5, that means that if the two patches edges are 5 units away from each other or less, it will generate or probably less than 5, it'll generate a off-mesh link between them for the AI to use. And the height is vertical height. Those kind of can be combined. So if the vertical height is set to 2 and the jump distance is 5, that means that if it's 3 high, it won't generate a link. It's pretty self-explanatory, but as long as you know what off-mesh links are. And then the advanced, this is kind of, well, I mean, it's advanced, so be expecting that, I guess. Height mesh will generate an accurate height mesh for precise agent placement. So this will create, I believe it will create a secondary mesh that is, so there's the nav mesh, which is low poly and relatively flat, and then there's going to be a secondary mesh that is a more detailed mesh to just determine where the object should be height-wise. So that way if you had like, you could have the nav mesh be flat across a road that is kind of like a gully, and the height mesh will determine the gully, and then you can go underneath the nav mesh. You can go vertically off the nav mesh a little bit here and there with your characters with the height mesh, but it's a little more advanced, so it's up to you. There's also the width inaccuracy and height inaccuracy. Basically, my understanding of these is, let me read this really quick. Yeah, I guess this is the amount of inaccuracy you're going to allow in the generation of the nav mesh, and the lower you make these, the longer it's going to take, the more data it's going to take to store your nav mesh, and I mean, you won't see a lot of the effects of it if you change it off the default, especially for like your earlier projects. But if you're seeing, I don't know, if you're seeing wonky stuff with nav mesh generation, play with it, see what you get. For example, if we increase this to 30 and we hit bake, I don't think we're going to see anything different. Oh, okay, so I think it decreased the. Yeah, I don't even think it decreased the polygon count. It did. Okay, so it decreased the polygon count a little bit. It made it a little more efficient, but I mean, it made it chunkier, and it didn't increase or decrease the bake time necessarily much. So I'm just gonna not mess with it for this video, but that's kind of what it does. The height inaccuracy is gonna change stuff like this, where we have this little bit of clipping going on in here. So if we change the inaccuracy to like 5, it'll make that a little better. Again, it's never going to be perfect, so you might as well just like accept that it's not going to be perfect and go with it a little. I don't know. Also, you'll notice the nav mesh is technically hovering a little bit above the ground, if you didn't see that. So you'll see that that's also what the height inaccuracy does. So if we change this to 1, for example, it's going to take a little longer to bake, but it'll be closer to the ground. That's all it does. I'm going to leave it at 10 because why not? And that's kind of what all the bake stuff does. There's layers for what you want the nav mesh to be. You can have multiple. The reason why you do this is you can have multiple types of Nav Mesh for multiple types of AI. So a game that was really, really fascinating to me Nav Mesh wise was, there was an Aliens game that came out a long time ago. It might have been Alien versus Predator, I don't remember which one it was, but the aliens could move across the ceiling and stuff. And I was actually in school for game development at the time, and I knew what nav meshes were, and I thought that was insane because it means that they created a nav mesh that was like a web of the inside of the structure so that AI could go on the ceiling and stuff. But no other AI could in the game, and you couldn't as a player. So that's different layers. They had a layer for the alien nav mesh, effectively. And at least I assume so. I don't know. I don't know anything about how the game was made, but I assume that they had a different nav mesh layer for the alien that was more detailed and could go on the ceiling and on the walls and stuff. And that's what layer it used to move. Everything else used a different layer, so kind of an explanation of how layers can work. But for this project, again, we're just going to go with one. We're going to hit bake, and we're going to have our nav mesh, and it's going to be great. So here's our nav mesh. So again, going back to what I was saying, where the nav mesh is effectively a roadmap of where the things using the nav mesh can go. Everywhere that is blue is the area that our character, our AI, our NPC, I guess, however you want to say it, our nav mesh agent, as Unity is going to put it, that's everywhere that it can go, is wherever it's blue. Wherever it's not blue, so like in these little dark areas and stuff, is where it can't go. And to demonstrate this, I'm going to go ahead and slap together a bunch of stuff, and I'm kind of going to explain what it is, and I'm going to, what it is that I'm doing, and I'm going to show you how it moves around. So to do this, to start this off, I'm going to create a sphere. Alright, and I'm going to move that sphere over to here. And I'm actually, now that we have a ramp, I'm going to move the camera back a tad to get that ramp in there. Move the camera down like that. Perfect. And I'm going to take that sphere and I'm going to move it up. Oh yeah, you'll also notice that if you ever leave the navigation window, the nav mesh goes away. So that's kind of nice. You can also check that. Actually, yeah. Anyway, so yeah, there's our cube, or our sphere rather. It's absolutely not a cube. I don't know why I thought that. I'm going to put it on the ground. I'm going to set it at 7 and -9 because I like rounded numbers. And well, I'm actually going to remove the sphere collider from this entirely because for this demo we don't need the sphere collider. For AI stuff in the future, you may or may not need a sphere collider with like a rigid body or whatever. For this particular example, we don't need any of that stuff. All we need on the sphere is a component, navigation, nav mesh agent. So a nav mesh agent is going to be what allows an object to move along the nav mesh. And you see there's a bunch of stuff over on the right there. There's also a cylinder that appeared over the object. So nav mesh agents are generally cylinders. And you can determine the side of how big it is by the height, and you can put an offset into the base if you want. So a lot of the time AI and things like that will have their pivot point at the base of the object. So the sphere has the pivot point in the center, but like your character that you modeled might have their pivot point at 0, which is where you want it to be, like at the bottom at the feet. And if it is there, then the cylinder that it uses to determine the bounding of your character is going to be centered on the bottom, which isn't what you want. So you want to be able to increase or decrease the base to offset it upward to be on the center of your object. It's not a big deal. It's just that's what that is. And the height. And I thought there was a radius. I guess not, though. Oh, the radius. It's right there. It's at the top. So yeah, we want this to be 0.5 because our sphere is a 1x1 sphere, which means that it's 0.5 radius. The sphere itself is. So that's good. There's also a speed. The speed is the movement speed it's like, yeah, think about the speed as its top speed, because we have an acceleration, and it'll kind of like slow to a start and then slow to a stop. And then we also have an angular speed. The angular speed is the speed in which it will turn to face its destination. Yeah. Stopping distance is how far away from its destination it will stop. That's kind of important. So it's almost like giving each destination a radius to say, hey, I'm here. Usually you want that to be 0, and you can handle that through your AI systems that you script instead. It's at least what I found. If you want, you can set this to something low, though, like 0.25, just so that you will always arrive at the location. You won't... if you can't quite get to the point that you're saying to get to for whatever reason, you can usually determine... There's usually a default stopping distance if you want that. So, for example, if you tell a bunch of AI to go to a point and not all of them can get there, if you set the stopping distance to 0.5, then as long as they get within 0.5 of the destination, they'll be there. So usually that'll usually encompass most of the AI that need to get there, depending on the amount. But obviously that's something you can control through scripting, how many you send to the point. So it's kind of a fallback. Auto traverse off mesh links is what this is supposed to say. Here, yep, doop doop doop. What that means is if there are off mesh links to get to the destination, it will automatically go between them. You don't have to have that if you're not using off mesh links, obviously. So, yeah. Auto braking, I believe, is will it automatically stop? Kind of makes sense. Auto repath, will it automatically rebuild its paths? Kind of makes sense. You want that to be on for what we're doing at least. I already talked about the height, the base offset, avoidance obstacle. What does this say? Obstacle avoidance type. In this particular case, it's how active do you want it to be in trying to avoid other obstacles? This cylinder is an obstacle. Think about it like that. Because if you go to component and you go to navigation, there is obstacle that you can put down, and it looks almost the same. It's a radius. It's a radius. It's a height. It's got a move threshold. And do you want it to carve the nav mesh or not? That means do you want it to punch holes in the nav mesh? Those we don't need right now because we don't have anything that isn't static. The idea behind an obstacle is that you put it on a so like say you have a quest giver AI that doesn't move. You don't necessarily need a nav mesh agent on that. You just need an obstacle on it, and then things that are using the nav mesh will avoid that obstacle, if that makes sense. You can also have things that will appear on the nav mesh and then disappear later. So things like destructible things in the environment. So if you have a big rock that's eventually going to get destroyed, you can put a nav mesh obstacle on it, and then when the object is destroyed, there's still nav mesh underneath it, and the obstacle is gone, so the AI can go around it and stuff like that. Yeah. So that's kind of what an obstacle is, and this is how active it is in trying to avoid those obstacles. Usually it's high quality. You usually want it on high quality, unless you have like an insane amount. Like if you're doing an RTS where you have 60 to 100 objects that are all pathfinding at once, you maybe want to put it to like low or medium quality, just to save yourself some calculation times. Make everything a little more responsive. The avoidance priority is if you have, sticking with the RTS example, if you have like a hero object who's really important, then maybe you want that person, and maybe he's bigger and more noticeable or whatever, maybe you want that the priority on his obstacle avoidance to go up some, so that you can he can avoid obstacles better, and he looks better because he's going to be the focus of attention. That's kind of what I was getting at there. Nav mesh walkable. So this is the layers of the nav mesh that you want this guy to use. So in the example that I gave earlier with the alien versus predator game thing that I saw, and the aliens could go on the ceiling, you would make a new layer for alien nav mesh, and then you would check he can go on every nav mesh, including the alien one, and everybody else can't go on the alien one. If that makes sense. So yeah, that's basically everything on the nav mesh agent. They're pretty straightforward. You basically don't need to mess. I'm not going to mess with any of this stuff because I don't need to. And you'll see why in a second. The next thing I'm going to do is I'm going to create an empty game object, and I'm going to call it Destination Creator. Now, this is actually just going to be a placeholder object. well, it's not a placeholder object, I wouldn't say, I guess. It's going to be essentially an object that is just going to be housing my code that I'm going to use to control my guy. And because I moved that, I'm going to go and remake Nav Mesh again, because there we go. Cool. Perfect. It's going to be an empty game object that's just going to house code, and it's going to kind of marionette the whole system here. So I have a thing here that I scripted called destination pointer, and I'm going to drag and drop that onto the empty game object, and it's going to kind of give me input control over the AI, quote unquote, here. And it's asking for a couple things here. It's asking for, first off, a target. That's the most important thing on there. So I'm going to drag and drop my sphere onto it, the thing that I'm going to move. And I'm going to name this Pathing Buddy, because he's my pathing buddy. So the destination creator says our target is the pathing buddy. That's the guy that we're going to create destinations for. It also has an accepted tag and a layer mask. I've been avoiding talking about layer masks quite a lot, and this is where we're going to need to talk about them. Like I said before, I have gone through all of these and I've tagged them all, and I have set up layers on them. So everything under the environment layer, which this needs to now be under the environment layer, so I can kind of walk you through how this is going to work. It's going to be called ramp. And I'm actually going to put, I'm going to put the floor material on this guy. Yeah. So everything in here has a specific tag and a specific layer. So the tag for this is going to be floor. So I'm going to go with env floor, which is one of the 3 tags that I made. I made walls, floors, and obstacles. There's a reason why. And they're all colored differently as well, because I'm a stickler for organization, things like that. So anything that's blue is going to be obstacles. This thing is an obstacle. Anything that is light gray is going to be a wall. And anything that is dark gray is going to be floor. So I know this because of the tags. env floor is going to be the ramp. The hub is going to be an obstacle. And these walls are going to be walls. You can see that by the tag changing up there in the top left. The top right, rather, I guess. They're all also going to be under the environment layer. Every one of these objects is going to be environment. So I need to change this to environment. And now this object is ready to go. The reason why that needs to be the case is because on my destination creator, it has a mask of all the different layers that it can detect. So the way this script works, and I will walk you through the script in a second, the way the script works is wherever I click in the game view, it shoots a raycast out from the point on the screen that I clicked out into the environment and sees what it hits. Whatever it hits, it will then determine if there is a point on the nav mesh near that thing, and then it'll tell the object to go there. So this environment mask is what can we click on to determine if we should be able to move there. And in this particular case, we're going to want to just detect the environment. So anything in the environment. If I click into the sky, it won't have me like move over that direction. It'll only have me move around on things in the environment. I also have a list of accepted tags here. This is so if I click on a wall, I don't expect to be able to walk up the wall because there's no nav mesh there, right? So if the wall has a separate tag than the floor. I only want to be able to click on the floor and have me move there. But the reason why I didn't just say put a layer for floor is because I do want to be able to click on the wall. I want the wall to be able to block my raycast. It's because I don't want to be able to click and raycast through the wall and then have the guy move behind the wall when I'm clicking on the wall. That seems odd and counterintuitive to me. So what I want to be able to click on the floor and have him move there, and if I click on the wall, him not move at all. So that's what this is doing. It's going to be really confusing. It'll make more sense as I show you the example and stuff like that. But for now, we're going to go env floor, which was the tag that we used for the ramp and the floor. See the tag? And with this set up the way that it is currently, I'm going to go ahead and save. With this setup the way it is currently, it will work. So if I click, oh, it didn't work. Did I screw up the tag on that? Oh, yeah, I did. I said EVN floor. It's ENV floor. There we go. So if I click, he'll move to that location. And just for kicks, I'm going to go back to the navigation tab over here so we can see where he's moving along. If I tell him to go up this ramp, he will totally go up that ramp. If I tell him to go behind this wall, he won't, because I can't see the floor behind that wall. But I can tell him to go over here, which is, if you look up here in the scene view, you can see he is behind this wall. And then if I tell him to go back over here, he'll pass behind the wall. He'll still path there, but I can't tell him to go anywhere that I can't see. So this is very much an RTS type thing, right? Like, you have your unit, you tell him to go where you click, and then they go where you click. So in this particular case, you can see that he's going to come in, and he's going to go around the obstacle in the middle, and he's going to come around this wall, and he's going to go exactly where we want him to go. So likewise, if I tell him to go into this nook and cranny, he's going to go as far into there as he can, and then if I tell him to come around to this side, he's going to come around the wall, he's going to come straight across, he's going to go around this wall, and he's going to tuck into that corner. So that's pathfinding. Unity has the built-in pathfinder. I didn't script the pathfinding. It just works. So if I tell him to go there, he'll come around the wall, he'll go around this obstacle, he'll come around this wall, and he'll go up there. I believe Unity uses some variation of A star. A star is basically, if you're interested in pathfinding and you want to know how to script your own from scratch, go look up A star and read the code on it. I did, and it made a lot of sense to me. And then right after I started scripting my own pathfinding system for my own uses, Unity came out with their own, and I was like, oh, cool, I don't have to do this anymore. It's kind of a headache. It can be, at least. I don't know. It's totally up to the person doing it, but I find it to be a headache. But basically what A-star does is it's finding the shortest path to the location that you specify, and using it, and then determining a series of points to go between to determine that path, to get that path to happen. So if I click over here, it is determining a path from here to there, and it's creating a series of vector locations that it's going to then feed to this object, and then this object is going to move along that path, along those series of points, if that makes sense at all. Pathfinding is bizarre, and I believe Unity uses A-star, which is a particular type of programming, a particular type of pathfinding algorithm is what I meant to say there. Words just kind of fall out of my head sometimes. I'm sorry about that, but I try to correct myself. So anyway, what exactly does this destination creator script do that is making it do that? Once we open up MonoDevelop here, and there we go. So, oh, come on. There we go. Excellent. So, we have our layer mask. And again, what a layer mask is a drop-down menu, right? So it looks, I don't know if I've talked about enumerators yet or not, but it's like an enumerator. It's not an enumerator technically, which is really weird. Layer masks are like one of the weirdest things I've ever encountered in programming, because if you look at what they actually say they say they're an int list. I guess not. I guess they're a struct now. Well, when I first started messing around in Unity, it said that they were int lists. So like an int of lists, like you would an int array. So int array equals new int array, like this. That's what it said it was, but it absolutely wasn't that. Maybe it was that in some form, but it absolutely wasn't just like an int list. So now I guess they're different. But basically, the only thing you need to know about layer masks is that's how you create one, and it's just going to be a list of all of the layers in Unity. I'm not exactly 100% certain on how to create defaults, so you just have to make sure that you set them up when you use them. So like when it comes in default, when I drag and drop the script on here, I'll do that again. Remove destination pointer. It starts off as nothing, and in this particular case, if you just run this with nothing attached to it, it's never going to find anywhere that it can read information from. So you want to make sure that you set it to environment, and I'm going to set up the tags again. Actually, well, here's an example of without the tags, because this is kind of important to understand how this thing works. So if I don't put a tag in here, and I run the project, I can still click around, and he'll still like go to the different locations, right? But if I click on this, he will move as close as he can to whatever I clicked on. So if I click on this thing, he'll find the closest nav mesh point to that object, or to wherever I clicked on the object, and he'll go there. So if you look up here, I have this little red debug line. If I click way up here on the top right corner of this thing, he'll go as close as he can to that point on the nav mesh, which is fine. But the reason why I put this tag list thing in is because if I click up here, I don't expect him to go below where I'm clicking. I expect him to go behind where I'm clicking, and that doesn't happen. So instead of compromising and saying, okay, you can click through things, or okay, you just go as close as you can to where the location is in 3D space, which is counterintuitive, I'm just going to say you can't. You just can't click on those objects, which is, I feel this is kind of going into designery stuff, but I feel like that's the most intuitive thing for the player. If they click on a wall and he doesn't move, you know you can't click on wall, so you have to click on the floor somewhere. That just makes a lot of sense to the player initially. Like it's intuitive is the point. So going back to the script, that's a layer mask. The layer mask is just a list of all the layers, and you can check which ones you are or aren't using later on in the script. The accepted tags, as I say, here's a semicolon separated list of accepted object tags for setting a destination. So if I wanted to use more than one, I just put a semicolon in and I type env wall. It's wall, right? It's not walls. Yeah, it's wall. So if I do that and I hit save, then I can click on walls. And he will... Oh, he doesn't. Oh, now it doesn't like anything. Oh no. Alright, well I haven't tested my script very well. That's something I can maybe figure out during this video. But for the time being, that doesn't work. And then we have our target, which is just a game object. So this is going to be a list of all the tags that we're going to accept, and this is going to be who we're going to target with our destinations. I also have a render last posed and last pose vector 3. So these are position little things. This is for the red debug line that you saw. I'll explain what those are in a second. I'm not using start. I can get rid of start. Oh. Wow. So I'm going to get rid of start. I am using update because every frame we're going to be checking for input.get mouse button down 0. That's the left mouse button. So if we right click, we won't assign a position. We will only get it if we left click. And this is kind of stuff that you've seen before. We're gonna do raycast hit. We're gonna raycast out. This I don't think you've seen. Camera.main screen point to ray. So this line, this chunk of code here, camera.main gets whatever camera first returns that is tagged with main camera. So what that means is there's only one camera in my scene, so it's going to return this camera. Because of this camera is tagged with main camera, which is a default tag in Unity. So it comes, like if you make a new scene in Unity and there's a camera in it, it's probably going to be tagged with main camera. Typically speaking, this is how I get the main camera. You can come up here and you can make a public camera object and say main cam, and then you can judge everything off of that instead. Or base everything off of that instead as the camera that you're using, or you can use camera.main and that will determine basically the same thing. If you have multiple cameras in your scene tagged with main camera, first off, that's not good. You probably shouldn't, because of reasons like this where there's a conflict. But also, this will return the first one, I believe. Yeah, I don't know. It'll return the first one, I guess. Screen point to ray will determine it will create a ray from the position of the camera. So if you think about a camera as a point in space, an infinitely small point, and then the perspective is angled off of here based on the width of the view, then you end up with positional coordinates of where... Sorry. So, if my mouse is here on the game view, I can draw a ray from the position that the camera is at to that position on the camera lens, and then I can draw a ray from that. It's kind of confusing, but basically that's what it does. You feed it a position somewhere on screen. Input.mouse position is what I went with, and it's a vector 3 for some reason. I always think it's going to be a vector 2 because this is a two-dimensional plane, the game view, but it's always a vector 3 for some reason. So there is a Z. I don't know why there's a Z, but it will create a ray, which is a ray is a type of a thing in Unity. It will create a ray from the mouse the position on the screen from the camera to that position outward, facing the direction of the camera. It's kind of hard to describe if you haven't noticed, but basically that's what it does. So this creates a ray, because again, one of the things you can do in Raycast is sorry, blip. One of the things you can do is you can feed it a ray, which is what we're doing here. This camera.main screen point array returns a ray, so we're just giving it a ray, and then we're giving it what to output to, which is our hit, our Raycast hit, and then we're giving it a distance, which is infinity. I want to cast infinitely into space until we hit something, and then I'm also feeding it the ENV mask, the layer mask, which is up here. So whatever we feed into this, whatever we check in the this thing, oh come on, there we go. So if we also check like everything, then it'll check everything. Nothing, water, environment. So this is what it's checking to see what it can hit, what we can click on, essentially, where we can click. Now if we do hit something, then we're going to open up our tag list here, and we're going to split it based off of a character, based off of that character. Now I thought, so this is the part that isn't working, and I don't really know why, but effectively what I'm attempting to do here is I'm attempting to take our accepted tags and split it by, oh, I know why. New character C equals maybe like that. Maybe that'll work. ENV wall. Sorry, I'm. Oh no. It doesn't like that at all. To be perfectly honest, I always forget how to do default. Whoa, come on. Maybe if we just. You like that? Nope, you don't like that at all. Oh, this bothers me so much. Anyway, we're just gonna ignore that. So split, basically what it does is you feed it a character, in theory, and then it will it'll cut up a string into chunks based off of that character. It's not working at the moment for me because I have this set up incorrectly, and I have to look into why. But I don't know, maybe in the next video I'll go back and say this is what I was doing wrong, blah, or I'll cut together something at the end of this and say what I was doing. But effectively what we're going to do, because it's a semicolon separated list, right? And if we feed a list like this into it, we're going to use env floor and env wall. And we're going to go through all of our tag list, and we're going to say, hey, do you have this tag? If you do, then we're going to trigger this boolean that says found. We're going to stop searching because found, and then we're going to move on to the next thing. If our tag list is basically empty, is what I'm asking here, because if you split something, it always returns at least an empty, or a list of that is one long where the first element in the list is empty. It's an empty string that looks like this. So you can't just say, hey, if my list is greater than 0, then great. If it's not, because it'll always not be greater than, or it'll always be greater than 0. So you have to make sure that the first element in the array is not empty. That's all I'm doing here. Anyway, if that's the case, then great. Look to see if we match any of them. If it is less than 0 or the first one is empty, then we go down here and we just say that, great, we're not looking for tags, so it's fine. Now, if we have found it, then we're going to set the new destination, which comes down here to this function. Set destination has a Nav Mesh hit. So this is where we're getting into the actual, away from the physics and into the physics scripting stuff that we've talked about before, and into the new nitty-gritty stuff. So a Nav Mesh hit is a lot like a Raycast hit. It's just where on the Nav Mesh did we find. So we have our float, which is a search radius. Right now it's defaulted to 10. You'll notice that that's not a public variable because I want that to stay consistent. I don't want it to be different on every instance of destination pointer. I just want it to always be 10. Or maybe 5 or whatever. I defaulted this to 1 earlier, and it seemed to work just fine. So I'm going to change that back. And I'll explain how this is used in a second. And then we're going to say if Nav Mesh sample position, what this does is we feed it a position, and we give it the Nav Mesh hit out, and we give it the radius, and it will give us, like a Raycast, it'll say, hey, did you find a position on the Nav Mesh near this within this radius? So it searches this position within this radius for Nav Mesh, and if it finds it, it'll return true, and all of that information gets output into the hit variable. Kind of like our Raycast. We say, hey, Raycast from this position out to this position, put all of our information into here, Raycast out this far, use this mask, yada yada. If you find anything, let me know, and we'll do this code. That's essentially what this is saying. Hey, Nav Mesh, here's this point. Is there anywhere nearby? Great. Let's use that point then. So this is stuff for our debug that I haven't talked about yet, so ignore that. These two lines are. And then our target, we're going to get the component for the Nav Mesh agent, and we're going to set the destination as the hit position that we found. So hit.position is going to be the position on the Nav Mesh that returned when we sampled. If that makes sense at all, great. Our debug stuff is actually pretty easy. We're just saying that, hey, if we're going to render the last position, which starts off false because we haven't input any position in, then draw a line from our target to the position that they're going into, the position that we set, and then make it red. That's all this does. And then down here, when we set our new destination, we make sure that we are rendering the last position, and we set the last position to the hit position. So that's just our debug stuff. That's not really important. This functions just fine without that stuff. It's just a thing that I put in so I could see what was happening. And I have my debug statements in here. You'll see those everywhere for hit tag mismatch. That means that we didn't find anything in our tag list. We have no idea what's going on there. Like we found an object, but it's not an object that we can click on to determine a location. So we're just not going to determine a location. That's basically what this means. Initial Raycast failed means that it didn't actually find anything at all. So I clicked into the sky, for example. And then this one down here, no Nav Mesh found within radius, search radius of point to location of blank. What that means is that we sampled a position, we clicked on something that we could click on, and it had the correct tags and everything, or we're not using tags. But when we got down to setting the new destination, for some reason we didn't find a location on the Nav Mesh. So what that could mean is that we clicked on an object that is tagged probably incorrectly, and we tried to find Nav Mesh within our radius of 1 of that object, but we couldn't find any. So either the Nav Mesh is generating wrong, or the object is tagged improperly, probably. That's just debug information for me to know what's happening. I'm going to save this, I'm going to come back here, and that kind of explains how that works. And this will let us, oh right, because tags are broken. Alright, Great. Yeah, we can click on stuff and we can go places. So, yeah. This is getting an object to move around on Nav Mesh. And that's all this video is going to talk about initially. And you'll see that, oh yeah, you can see that if I select that guy, our pathing buddy, he's actually turning to face the location that we want him to go in. That's what the angular speed is. So if we increase this to like, I don't know, 360, he'll like snap pivot around. So, pathing buddy, he'll like really move around quickly. You also see all the sorts of other crazy debug information on him, like arrows pointing in crazy directions that like shrink. Those are movement vectors, and they are like physics vectors, so they're like acceleration and so you'll see like the black arrow is where he's pointing currently, and the speed in which he's moving in that direction is the length. So it's actually the speed that he's moving in that direction. And then the other arrow is the his heading, his max speed and heading. Also, you'll notice that it draws his path out. So if I decide to go this way, it'll actually draw out his path along that nav mesh there. Let's so we're there, and then we do this. So it's actually drawing this little red line, and once he gets to this point, it'll start drawing further ahead, I believe. Yep. So it draws a certain number of points ahead. So that's just more debug information. If you have the Nav Mesh agent guy selected, then that's what happens. It's arguably more visible on the blue, but yeah. So, but I have the debug line in just so I know that it's the destinations are working and everything like that. So, yeah. So this is how you get an object to move around in the Nav Mesh. In the next video, I'll probably be talking about how to make this happen idly. And what I'm probably going to end up doing is I'm going to script something that I hopefully test a little more than my destination creator, because that tag thing didn't work out right, but that's okay. I'm going to script something that basically has it chooses random locations within a radius. It has a bunch of debug information that it kicks out, and it's essentially just going to be idle movement. And I'm also going to script a bunch of other stuff, and I'm basically just going to walk you through how I scripted it and show you examples of it working. I feel like that's going to be the best way to do what I'm doing here, because this is kind of like I said, it's an advanced topic, and I don't want I say I don't want an hour-long video as I look at the timer and it says an hour and 2 minutes, but I would rather they were as short as possible, and I feel like this is such an advanced topic that I should just do the work first and then explain what I did instead of walk you through every step. And with the knowledge that you have in this already, you can already kind of see that making NPCs and stuff in games isn't that hard. It's just, well, in Unity, in the new engine, making dumb AI is pretty easy. Making advanced AI, emergent AI, is very hard. And I'm not saying that the engineers that work in game studios are like, oh, their job's so easy. No, their job is the hardest job in the game studio, probably by far. I'm constantly impressed by AI in games. I think that it's extremely impressive, and I've worked with a few guys who do AI engineering in games, and man, they know what's going on. They are great. But this will get you moving into a direction. This is like super stupid simple stuff. You're getting a guy to move around on Nav Mesh. That's like the first building blocks of being able to make AI, right? Next is having them determine where their destination is going to be like another step in that direction. So if we do idle movement, then they're determining where they're going. And then after that, we can do something along the lines of like investigating. So maybe they see something and then it's gone. So then they go over to where they last saw it and they like look around. Which implies a lot, right? That implies that they have a view cone. They have a cone of vision. Or they have a different states, right? They have like an investigative state where they're looking for something. And then they have like an idle state where they're just wandering around. So again, this is all implying quite a lot. So in the next video, I'm going to hopefully have scripted something that's a little more advanced than this point and click kind of setup. And we will be able to investigate that a little further. But for now, I hope this was helpful. And yeah, until next time. Thanks for watching, and bye-bye!